The Leaning Tower of Pisa is approximately 179 feet tall. The height of the ball dropped from the Leaning Tower of Pisa follows the equation S of t equals 179 minus 16t squared. Okay, so imagine you're standing on the top of the tower and you drop a ball, right? So the height of the ball is given by this equation. This is the position equation, right? Where t is in seconds and height is in feet. So we want to find the equations for velocity and acceleration. How long does it take for the ball to reach the ground? And we want to find the velocity of the ball right when it hits the ground, okay? Remember, this is a position equation, right? 179 minus 16t squared. Okay, so the velocity is just going to be the first derivative of this guy. The derivative of a number is just 0, so we get negative 32t. And then the acceleration equation is the first derivative of velocity, which is negative 32. Okay? That was a little bit interesting, right? What does this mean? It means that the acceleration is always negative 32 feet per second squared. Okay? And that's true for falling bodies, right? Anytime any falling body, the acceleration due to gravity is negative 32 feet per second squared, right? Also 9.8 meters per second squared, right? But this one's in feet. Okay? So we found the equations, right? We found the equations for velocity and for acceleration. Okay, so now how long does it take for the ball to reach the ground? Okay, well, what does that mean? Well, how do we know when the ball hits the ground? The ball hits the ground when S of t is equal to 0, right? When that position is 0. Think about this. What is S of 0? When you put 0 in here, okay, at 0 seconds, the height is 179. Yeah, so we want to find, okay, when does the height equal 0? Well, we just set the equation here, equal to 0, and we'll solve this guy, right? So 179 is equal to 16t squared, okay? So what I want to do now is divide both sides by 16. So t squared equals 179 divided by 16, which is approximately 11.1875. And then, well, not finally, but we need to take the square root of this, right? So t is going to be approximately, right? Approximately 3.3 seconds. So after 3 seconds, right? Or 3.3 seconds, the ball will hit the ground, right? What is the velocity of the ball right when it hits the ground? Well, that's just the v equation, right? So we know the time, right? At 3.3 seconds, right, the velocity v of 3.3 is about negative 32 times 3.3, right? So 32 times 3.3 here gives us approximately 105.6 meters per second here. Okay. It should be negative. Right? Very important. Why is it negative? It's negative because the object is moving down. Right? Anytime the object moves down, the velocity is negative. Anytime it goes up, right, the velocity will be positive. We got to be careful though, right? Here, acceleration is always negative. It's a falling body, right? So the acceleration due to gravity is always negative 32 feet per second. Oh, sorry, this should be feet here, right? This should be feet.